Hello everyone and Assalamualaikum. We from Group 5. So today my team and I are talk to you about 5-axis machining. We created this video presentation to show you what we learned and the project journey of this project. So I hope you enjoy this video. Okay, I would like to introduce our group members. First one is my name is Nurhuda binti Sarman, and the second one is Quratul Aina binti Zulkarnain, and the third one is Alia Nur Fatiha binti Mat Yusuf, and the last one is Siti Fatiha binti Yusuf. Okay, introduction. So basically for this project, we designed a dome. So basically a dome is an architectural element similar to the hollow upper half of a sphere. It is an ancient and versatile architectural features that has been used in various culture and time period for different purpose. We choose a dome part because of the design look is complicated and challenging to process. In designing the part, we use a CATIA software. CATIA software is widely used in engineering and manufacturing industry for designing and modeling complex 3D product and system. One of the advanced capability of CATIA is to support for 5-axis machining, which enable precise and efficient machining of complex geometry. We have three objectives. The first one is to analyze and understand the principle technique that involve in the design and implementation of advanced machining process. And the second is to develop the machining process that involve in the production of the part. And the third is to produce the part using 5-axis CNC milling machine. Project planning. So this process is to determine a project objective, scope, deliverable, timetable, resources, and overall strategy that known as project planning. It requires meticulously describing the activity, milestone, and tasks that must be completed in order to properly finish a project within the parameter have been set. The act of define, organizing tasks, resource, schedule, and goals is needed to successfully finish a project. In the management of project, this phase is essential since it lays the ground for the project completion and control.
Assalamualaikum warahmatullahi wabarakatuh. My name is Alia Nur Fatiha binti Mat Yusuf and I will explain about the task allocation. So for completing our project, we divide some tasks between our group members. Firstly, Quratul Aina binti Zulkarnain, the task is 2D drawing, 3D drawing, and the report is introduction and project planning. For Nurhuda binti Sarman, the task is CAM machining and process. Meanwhile, for the report is conclusion. Thirdly, Alia Nur Fatiha binti Mat Yusuf, the task is CAM machining and process, and the report is 3D modeling and process planning. Fourthly, Siti Fatiha binti Yusuf, the task is compiling and editing report video. Meanwhile, for the report, mentioning simulation, result measuring, and discussion. So, next is the plan chart slide. As you can see, this is our planning to complete the project of subject Bmmp 3484. Advanced machining started from the selection of part design, drafting proposal, and submission until site preparation and project presentation. We start our project machining process late, which is in the week 16 due to some problem during our preparation. Okay, next is the process planning slide. So for the process planning, it is distributed equally to our group members. There are 9 processes in total. For the design idea, it is made by all of us. Meanwhile, for the entering sketch of 2D sketches is made by Aina and part design workbench is made of Huda. For the preparation to come until machining sheet is made by all of us, and video simulation is made by Fatiha, and lastly, report is being done by all of us. Okay, in addition for the machining sheet, it is basically about our machining process plan for completing the project. We form group 5 and our part name is a dome part, and the machine that we use is TMG Mori 5-axis milling machine, and the material that we use is aluminium. As you can see, there are a 5 steps for our project, which is facing, roughing, profile contouring, isoparametric, spot drill, and drilling deep hole. The tools that have been used for facing is face mill diameter 63. Meanwhile, for the roughing and profile contouring, we use end mill diameter 20, and for the isoparametric, we use ball mill diameter 5, and for the spot drill, we use chamfer, and for the drilling deep hole, we use a drill diameter 7.
My name is Curator Aina binti Zulkarnain. I will present about 3D modeling. So the first is isometric view, the second is top view, the third is right view, and the fourth is a front view. Next is the machining simulation. For the first, we do a part, stock, and plane system, and then we create a cutting tool creation. And then is machining process. For the first process is facing. We use the face mill diameter 63. After that is roughing process. Roughing process we use end mill diameter 20. Next is the profile contouring process. We use the same tool which is diameter 20. For isoparametric process, we use tool number 3 which is ball mill diameter 5. Next is the spot drill process on the base area. We use tool number 4 is spot drill diameter 10. For spot drill process on the dome, we use the same tool which is diameter 10. After that, drill process on the base area. We use tool change number 5 which is drill diameter 7. We also use the same tool in drill process on the dome area which is diameter 7. After finish all the processes, this is the final of our project.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Fatihah binti Juso. So in this presentation video, I will cover two parts, which is discussion and conclusion. So for the discussion, we cover about the problem that we have faced when doing machining and how to overcome the problem. So the first problem is we can do the process isometric on the semi-cycles of our product. This is because of limitation of machine. So the solution that we suggest to do is do a multi-axis plane. We suggest this solution because when we use a multi-axis plane, the direction of tool can come straight up, down, and also left and right, or in other way, it can come from many directions, not only one direction. So the second problem is we can do spot drill process. Okay, the solution that we suggest is we have to rise up drawing or extend the tool point. So when we increase the drawing, cause the tool to move up to cut higher and thicker material. So this makes easier to deal with thicker material or make deeper cuts, enables it to create design with greater complexity and intricacy. The conclusion is 5 axis as one machining can move in 5 directions at once because to their ability, which give them incredibility, fine control, and versatility. So manufacturer may use this technology to produce intricate and stunning design on a variety material, saving time and result a high quality of product. So modern production require the use of 5-axis machining since it offers up new possibility in sector like aerospace, automotive, and also in medicine sector. Besides, having an issue with CNC machine is similar to running into a barrier throughout the production process. It may be frustrated and also result in mistaken and production delay for part and component. So, but it's important to keep in mind that difficult are an inherent part of any technology and procedure, and that this problem may be solved with skill and also the knowledge. Therefore, we may continue to develop and fully realize the potential of CNC machine in streamlining and improving the way we manufacture things by identify and confronting these challenges. So that's all.